Hi, welcome to the session number 6, video number 4, Sequence Activities Process. Sequence Activities Process. Sequence activities is the process of identifying and documenting the relationships among the project activities. The key benefit of this process is that it defines the logical sequence of work to be obtained, the greatest efficiency given all the project constraints. This process is performed throughout the project. Let's try to understand how exactly the sequencing is done. The process of identifying and documenting the relationships among the project activities is what happens here. Key results of this process is the network diagram. The network diagram shows the dependencies of the activities. If activity durations are added, it's also showing the critical path. Every activity except the first one and the last should be connected to at least one predecessor and at least one successor activity with an appropriate logical relationship. Logical relationships should be designed to create a realistic project schedule. It may be necessary to use lead or lag time between the activities to support a realistic and achievable project schedule. Sequencing can be performed by using project management software or by using manual or automated techniques. The sequence activities process concentrates on converting the project activities from a list to a diagram to act as a first step to publish the schedule baseline. As you see in the figure, many activities that have to be carried out in order to complete the project work will be arranged with their relationships. In this example, you see that activity 1 is the first activity as the project starts. Activity 2 and 3 are dependent on activity number 1. That essentially means without completing the activity 1, you are not able to start working on activity 2 and 3. Similarly, the relationships between all the other activities will be shown in the network diagram. Now let's have a look at the types of relationships. There are 4 types of relationships that can present in any given network diagram. These 4 types are namely finish to start, start to start, finish to finish, and start to finish. The very first example you see here is representing finish to start. Activity B can only be started once the activity is completed. This forms finish to start relationship. The second example you see here on the left side of this figure is start to start. That essentially means as soon as activity A starts, activity B also can be started. It doesn't mean the activity A and B will start at the same time. It's just that as soon as activity A starts, anytime sooner, activity B could start. So that is the second type of the relationship. The third type of the relationship is finish to finish. So as the figure explains, activity B and activity A has finish to finish relationship. What does that mean? It means when activity A is completed, activity B also can be completed. So unless you complete activity A, you will not be able to complete activity B. But again, these two activities don't have to be finished at the same time. It's just that for activity B to be finished, activity A must be finished. So that is the third type of the relationship. The fourth type of the relationship is start to finish. As you see, as the activity A starts, activity B can be finished. Again, as soon as this is started, activity B could be finished anytime sooner. So that is the fourth type of the relationship within a network diagram. Now let's have a detailed look at some of the examples for these four types of relationships. Finish to start. This is the most common type of dependency and is the default type of dependency that project uses. In a finish to start dependency, the second task in the relationship can't begin until the first task finishes. So, for example, if you were planning a project to make a wedding cake, you might use a finish to start dependency between the bake cake and decorate cake tasks. When the bake cake task is finished, the decorate cake task can begin. Let's have a look at the second type of the relationship with the same example. That is start to start. Start to start dependencies are used when the second task is in the relationship can't begin until after the first task in the relationship begins. Start to start dependencies don't require that both tasks start at the same time. They simply require that the first task has begun in order for the second task to begin. Going back to the wedding cake example, let's say you had planned to make the icing for the cake while the cake is baking in the oven. You can't start making the icing until the cake has started baking. So you might use a start to start dependency between the bake cake and make icing tasks. The reason for this could be you don't want to make the icing prior baking has started. While the baking happens, you may do a few activities in making the icing. The third type of the relationship is finish to finish. One of your tasks can't finish until another finishes. You can use a finish to finish dependency between them in this case. Finish to finish dependencies don't require that both tasks are completed simultaneously. They simply require that the first task be finished in order for the second task to finish. The second task can finish anytime after the first task finishes. In our wedding cake example, let's say there are some finishing touches to the decorations that you can't finish until the cake is delivered. You can use a finish to finish dependency between the decorate cake and deliver cake tasks. When the decorate cake task is finished, then the deliver cake task can be completed. The last type of the relationship, start to finish. Start to finish dependency is little tricky. When you use this type of dependency, you are saying that the second task in relationship can't finish until the first task starts. However, the second task can finish anytime after the first task starts. Going back to our wedding cake example, let's say you have a task for billing the customer. It begins when the customer requests the cake, but it can't be completed until after the cake delivery has begun. You can use a start to finish dependency between deliver cake and bill customer task so that when the deliver cake task has begun, it's okay for the bill customer task to finish. So if you put all these four types of relationships together, you'll see making the wedding cake example in this way. Now let's have a look at four types of dependencies. There are four types of dependencies that can be used in your network diagram. First type is known as mandatory dependencies, also known as hard logic. Mandatory dependencies are inherent in the nature of the work. Example, you cannot test screen before you develop it. The second type of the dependency is known as discretionary dependency or preferred, preferential, or soft logic dependencies. These dependencies are determined by the project team and can be changed in order to shorten the project. Example, John's activities order changes from A to B to B to A. The third type of the dependency is known as external dependencies. As the name suggests, these dependencies come from outside the project. Example, government, suppliers, or any outside vendor who is involved in the project. The fourth type, which is the last type of the dependency that exists within your network diagrams, is internal dependencies. Internal dependencies involve precedence relationship between project activities. Example, you cannot start construction before design finishes. This is an internal dependency. These internal dependencies can be adjusted based on your need. Of course, depending on what the nature of the task, what exactly you are trying to achieve, they will define the relationship. Now let's have a look at two terms that you need to learn in terms of learning sequence activities process. These two terms are leads and lags. First, let's have a look at the lead or lead time. The successor activity starts before the other activity finishes. Example, coding might start 5 days before the design finishes. So as the figure indicates, the design goes until this particular point. So your coding starts 5 days prior finishing the design work. So the lead time is the overlapping time, that is 5 days. Now let's have a look at the next term, that is lag time. The successor activity starts after the other activity finishes. So the gap between the first activity finishing and starting of the next activity is known as the lag. Example, wait for 3 days after pouring concrete to start constructing the frame of house. So here the lag time is 3 days that you wait after pouring the concrete to start constructing the frame of the house. Now let's have a look at one example. If you consider the same example we discussed earlier in this video, that is producing a billing system, we had one work package called invoice screen, and that work package is divided further into 4 different activities. Then, namely, analysis of the invoice screen, design of the invoice screen, development of the invoice screen, and test of invoice screen. So if you consider the first 2 activities, that is analysis of the invoice and design of the invoice, I can say analysis of the invoice screen starts here. And after starting the analysis of the invoice screen, after the next 10 days, the design of the invoice can start. So this is how you indicate that in your network diagram, SS plus 10 days, which indicates that this has a start to start relationship, and after analysis of invoice screen has started, after 10 days, you can start the design of the invoice screen. After designing of the invoice screen, you can say the development of invoice screen can start. In this case, I'm saying there's no lag time or lead time. It's just that between design and the development, there is a finish to start relationship. That is to say, as soon as the design of invoice screen finishes, the development can start. All right, now let's have a look at the last activity, that is testing of the invoice. Here, between testing and development of the invoice, we have a finish to start relationship. That is to say, as soon as the development of invoice screen finishes, the test of invoice screen can begin. But in this case, we have a lead time. What does that mean? This is saying 2 days prior the development of invoice screen finishes, the testing of invoice screen can begin. How you indicate that in your network diagram is saying finish to start relationship FS minus 2 days. Hope this is clear, and this knowledge, understanding these 4 types of relationships, indicating the lead time and the lag time, is so crucial for you to build up your network diagram. Up next is estimate activities process. I'll see you there.